Hi, this is Praveen. This is my video submission as part of probability homework 6. So in the first problem, we are given the joint density fxy equal to b. It is within the range x square plus y square is less than or equal to 1 and 0 otherwise. So x square plus y square less than or equal to 1 can be is nothing but a circle, a unit circle with the center at origin 0 and radius 1. So writing this in polar coordinates, we have x equal to r cos theta and y equal to r sin theta, and dx dy is r dr d theta. And also from this, x is nothing but root of 1 minus y square, and y is root of 1 minus x square. And taking the plus or minus values, x ranges between minus root of 1 minus y square to root of 1 minus y square, and y ranges between minus root of 1 minus x square to root of 1 minus x square. So we know that the integral of the PDF is 1. So now the range is, for x it is from 0 to 1, and for y to get the area of the circle, we integrate this line over the circle. So theta varies from 0 to 2 pi. That is what we have done here. So integrating, we get b equal to 1 by pi. Now expectation of x is nothing but integral minus infinity to infinity integral minus infinity to infinity x f of xy dx dy, since it is expectation of x. So again, taking the x limits from minus 1 to 1, and the y limits are nothing but, as we saw here, they are from minus root of 1 minus x square to root of 1 minus x square. So integrating, we arrive at this final expression, 2 by pi integral minus 1 to 1 x root of 1 minus x square dx. This is 0, since this function is an odd function. So replacing x by minus x in this, we end up with minus f of x. So similarly, e of y is nothing but, we can take the x limits from minus 1, y limits from minus 1 to 1, since it's a unit circle, and x limits from root of 1 minus y square to minus root of 1 minus y square to root of 1 minus y square. It is also equal to 0, and the expectation of x given y is nothing but integral minus infinity to infinity x f of x given y dx. So f of x given y is nothing but f of xy by f of y. So f of y can be found by integrating out x. So f of y equal to integral minus infinity to infinity f of xy dx. So the x limits range from minus 1 to 1, and f of xy is 1 by pi, as we found in the first step. So we get the answer as 2 by pi. So now finding f of x given y is nothing but f of xy by f of y. F of xy is 1 by pi, and so divided by f of y, we get f of x given y as 1 by 2. So now using it in the formula of e of x given y, we get e of x given y equal to integral minus infinity to infinity x into f of x dx. So which is nothing but, we end up with 0. Similarly, e of y given x is integral minus infinity to infinity y into 1 by 2 dy. So the y limits range from minus 1 to 1, and similarly we get 0. Now we are asked the general e of x given y. Here we use the y pertaining to this problem. So y and x pertaining to this problem. So here x and y range from minus 1 to 1. So using the general x and y, so we know the general expression for x and y, which is given, we can reduce it from here. So using that, we will we will integrate from minus infinity to infinity x into f of xy dx for e of x given y. So to find f of x given y, in this specific case, we find f of y between the integral minus root of 1 minus y square to root of 1 minus y square. So we get that as 2 by pi root of 1 minus y square. So now finding f of x given y from that, we get the expression 1 by 2 root of 1 minus y square. So now using that in this expression e of x given y, so now we integrate generally over this range for the x interval. So integrating, we get 0. Similarly, e of y given x, where y and x are generalized, not pertaining to the specific problem. So we get e of y given x similarly as 0. Thank you.